Hi, Yr11. I'm going to do 3 or 4 videos in this one page to cover over Monday and Tuesday. So just work through them systematically, one at a time, do a few questions. I'll point out which questions relate to those kind of concepts. And we're going to be looking at trigonometric identities. Now, in mathematics, this idea of identity is a relationship that holds no matter what the angle or the pronumeral value might be. So it's a stronger idea than an equation. It's this idea that it's always true. And so, as an example, a thing that's not an identity is that, well, sine 45 is equal to cos 45. That's true, but you see how it has to be for a specific value of theta, for an angle. But it's not always true for any angle. Sine and cos are not equal to each other all the time. But there are identities which are always true, that have relationships between two trigonometric ratios. So we're going to look at 3 categories and see if we can work our way through over a couple of days. Okay, I'd say that they're all kind of important to get a good sense of how these relationships work. If questions come up, write them down, send them to me, ask each other. It's good to help each other with them. So let's have a look at the first one, which called reciprocal trigonometric ratios. Reciprocal. So remember that the other reciprocal is 1 over. And so here we're going to introduce these 3 new words: secant, cosecant, and cotangent ratios. All right. And these are defined by sec theta equals 1 over cos. Now the trick is to remember the third letter, actually, C and C. Now, most of the world actually does cosec as CSC. We in New South Wales tend to do this. Cosec theta is equal to 1 on sine theta. Right, so cosec, so if I look at the third letter, cosec and sine, and then cot and tan. And so they're 1 over. Now, functionally, if I was to draw a triangle and say, okay, what do these things mean? It's just a different way of expressing another ratio within a triangle. If my angle theta is here, and let's say we have A, B, C, right? So in this case, well, let's say cos theta is adjacent over hypotenuse, B over C. But if I took its reciprocal, sec theta would be the reciprocal, which would be C over B, the hypotenuse over the adjacent, right? And if I did that for sine as well, sine theta is equal to A over C, opposite over hypotenuse, whereas cosec, or CSC, cosec is equal to C over A, right? So again, it's all about what context, what function. There's a particular function as well that we'll see. They do pop up in different contexts, so that's why they've sort of been defined. But we need to be aware of these. So I'll just, for you to make a note to yourself, sec, cosec, or CSC, and cot. They're the reciprocals of cos theta, sine theta, and tan theta. And similarly, I should add, we could also write these as cos theta is equal to 1 over sec theta, all right? And etc. So make sure that you are, they're the same thing back and forth. If I was to think of it like that, we can switch places. So make sure you're clear on that for all 3, right? That sine theta is 1 over cosec theta and tan theta is 1 over cot theta. So moving on, if I was to do an example, okay, well, this type of question you should be getting familiar with now, where we say, okay, sine theta is equal to 5 on 7, and find the exact values for sec theta, cosec theta, and cot theta. So I'm going to just go ahead and do the whole lot, so we sort of visualize how they all relate. I'll do a very crude, simple triangle, doesn't matter. 5 on 7 means 5 is the opposite, 7 is the hypotenuse. It's not to scale, it doesn't matter. So if I said x is that, well, x squared equals 7 squared minus 5 squared. And so that's 49 minus 25, which is 24. 24, so x is equal to square root of 24, which to me gives me 2 root 6. 2 root 6, right? If we simplify the third. So I can just write here 2 root 6, so I know what that is. So I can basically just go ahead and say, well, cos theta doesn't require me. I'm just doing it as a exercise. 2 root 6 over 7. And tan theta is equal to opposite over adjacent. 5 over 2 root 6, which I could rationalize the denominator. I'm not going to. So I can then go ahead and say, well, sec theta is the inverse, sorry, not the inverse, the reciprocal of cos. So it's the upside down. We switch the denominator and numerator. 7 over 2 root 6. Cosec, remember it's CSC or cosec, you can write it out either way, is equal to 7 on 5. It's the reciprocal of sine. And cot of theta is equal to 2 root 6 over 5. 2 root 6 over 5. And that's it. So we just need to understand that sine, cos, and tan have these reciprocals, which aren't just one on sine or one on cos. They're actually defined as sec or cosec and cot, depending on which one we talk about. So this is the first set. Go and have a look at some of the questions, and I'll write in next to the video what questions you could have a go at. Thanks.